this will serve as my introduction to my Volkswagen project. I have a 1969 Volkswagen Karmann Ghia, and it's got a broken transmission in it. So this whole project is a very roundabout way of fixing a broken transmission. So the transmission that's in it right now is what you call a Pro Street transmission. It's a factory Volkswagen transmission, a little bit stronger on the inside. And the engine bolted to it is a custom fuel injected 1915cc Type 1 Volkswagen engine that I built when I was in college. And this little engine puts out a decent amount of power. And I think my biggest problem was that I added a launch control button and I lost first gear. And not too far after that, I lost fourth gear. So the car can still be driven around in second and third gear and reverse, but it's a pain. So before I had this Pro Street transmission, I had a stock Volkswagen transmission, blew that one up. Figured a Pro Street could handle it, but could not handle it. So I just got really tired of Volkswagen stuff. You know, the transmission was designed in like the 1930s, and the original Volkswagen engine was a 25 horsepower engine, and that transmission always leaks. I know you can spend a bunch of money on upgrading a Volkswagen bus transmission. Didn't want to go that route. Wanted to do something a little more different, a little more exciting. So here we are. This is a Subaru 6-speed transmission. It is a split case transmission. It's different than the 6-speed STI transmission, which is a great transmission. This will be going into that car. Now I'm sure you're wondering about this sitting next to me. This is a JDM H6 or EZ30 Gen 2. This is a 3-liter flat 6 engine. Now I decided to get this because the adapter plate to bolt the flat 4 Volkswagen engine to that transmission. So the adapter plate and Flywheel is like $1,300, whereas this JDM engine from an importer was $1,200. So there's going to be extra work to throw this in there, but in my opinion that's kind of worth it. You know, there's going to be some extra work and some extra cost, but you're talking about a 3-liter versus a 1.9 Volkswagen. From the factory, this is supposed to make 240 horsepower at the crank, and that's with all the factory equipment on it, factory intake, factory exhaust, and yeah, everything factory. That little guy makes about 120 at the wheels or so. Never been on a real dyno, but that's about where it sits. So for a little more effort, time and money, you get something way newer, double the horsepower, way more reliable, water cooled. I don't have to worry about cooling in the Southern California heat. And we'll see how it goes, but I may actually keep the air conditioning. So having an air-conditioned classic Volkswagen would be amazing. So we'll see how it goes. So let's talk about a little bit of the specifics of the build and why I went this route, why I didn't go other routes. So everybody throws the 4-cylinder Subaru engine into the Volkswagens. That's a very, common swap done all the time. Nothing wrong with that. I wanted to go that route. Decided against it. The EJ25 engines, the 2.5-liter turbo. That's an expensive build, expensive little engine. This guy is. This comes out of like the Tribeca, like the mid-2000s Subaru 3rd-row seat mom SUV. So it's not the most desirable engine. It's not like the hot swap that everyone wants. I mean, this thing revs to about somewhere around 7,000 RPMs. It's got 4 overhead cams. It's got variable valve timing and variable valve lift. So it's got all the, it'd be nice if it had the variable valve stuff on the exhaust, but it doesn't. But I mean, it's got all the core components needed to make a good amount of power and run well in that naturally aspirated format. If I ever decide to put a turbo on it in the future, I mean, it's already got the displacement to be a real nice build. Yeah, so this, oh, and the other main thing, the H6 has a single accessory belt instead of 2 accessory belts. And instead of timing belts, it has a timing chain. I believe this was the first Subaru engine to have a timing chain. So even though it's got a whole 2 extra cylinders, it is only 0.8 inches wider than the EJ25. So in terms of fitting it into this car, no problem. I've already seen swaps where this engine's been put into a Karmann Ghia. They typically end up cutting the pan right around here, and you know, of course, wider as well, but it's really not that much material to remove. So for this build, I'm going with a Megasquirt MS3 ECU. I got that in the mail recently, so that's going to be a fun project getting that to run. I do have experience with Megasquirt, so that's kind of why I'm going with Megasquirt versus you know, factory Subaru ECU or similar, right? So this car is run off a Megasquirt MS2 unit called the Microsquirt. So I did everything on this car to build a fuel injection system from scratch. So when I first started, I only had a narrow band exhaust O2 sensor and a, let's see, I had a map and a throttle position sensor, and that's it. And I you know, made lots of mistakes on this little engine, and I learned what every other sensor does and why it's important and how it affects the fuel maps and all that. So since then I've added much more to this car, and now it's got a wideband O2, and yeah, it's set up with a really good map. I don't have to use, you know, huge correction factors on the wideband. So I've kind of done my homework and learned how not to do Megasquirt and how to do it correctly. So it should be a fun project setting this one up. So the transmission. This is not a one-to-one bolted in swap. I wish it was, but it's not. This transmission needs to have a reversed ring and pinion gear thrown into it. Now I'm going to be doing the SubaruGears conversion. So that takes the ring gear and it reverses the teeth on the ring and pinion, and it flips it over to the other side so that when the pinion shaft is driving the gears, it drives it with 6 forward gears instead of 6 reverse gears. So that's, you know, oh, hey cat. That's not the hey cat. That's not the most complicated part of the swap. The SubaruGears swap is pretty well documented. It's a pretty common swap. What's a little less common is this is a TY751 transmission. So this is the newer model split case 6-speed. So that's this one. This family of transmissions started being produced in about the 2010s, and it's still produced today. And this one goes into like the mom cars, the wagons and stuff. Yeah, it's not your STI. It's not a spec B transmission. It is very similar to the original 5-speed, but there's some differences that make it a much better transmission. This little cat is just obsessed with me right now. So let me go grab the 5-speed. I'm going to set it here, and we're going to go over the differences and why I think the newer 6-speed is a much better transmission to build with. So we're going to pause here. Alright, so when I was planning this build for the last 5-6 years, back then I hadn't done the full research I should have, and from a neighbor I acquired a TY754 5-speed out of a 2002 car. Nothing wrong with this transmission. It would work fine in that family of car. Would not do very well with a 3-liter with a lot of torque and probably launch control. It's very well documented from the early WRX cars that the 5-speed transmission does not hold up to any serious output. It's got a lot of inherent weaknesses, and in order to make this guy work, you have to spend a good amount of money in upgrading the gear sets, and sometimes people add on external bracing that literally clamps the transmission halves together. You can also upgrade to larger grade 8 bolts, and you can torque them tighter. But basically the core case of this transmission is just not very strong. So in a minute we'll go over what's the difference between the two. I do want to say though that folks have put this transmission in a welded steel frame, a stand. They've secured this thing the same way it would be secured in an engine bay, and they take torque wrenches and whatnot, and they put a whole bunch of torque on the input shaft with the axles locked, and you can put like a dial indicator from a fixed point onto places around the transmission case, and they were able to measure noticeable flex in the transmission. There was also a, what's his name, the guy that runs Rally Spec, the gear seller company. He worked with an engineering senior project, engineering school senior project, and they drilled a hole through the side of the case, stuck the dial indicator on the shaft itself, and did the same process, and they were able to measure that the shaft was actually flexing, and you know the teeth engagement was getting way out of spec. So the old way to solve that was just to spend thousands of dollars on really hard, strong gears that could survive torque and shock load while the gears weren't properly fully meshed. So this little 5-speed unit would work okay behind that Volkswagen engine, but I don't think it would last on this one, not with the abuse that I want to put through it. So let's talk about the differences between them. So I'm hoping this lighting isn't too bad. You know what, let's just make it shade so we can see a little better. There we go. Okay. So if we look at the bell housing here, and we look at these two, there is way more webbing, way thicker, a lot more ribbing. There's a whole lot more material bracing this 6-speed transmission. Now if we look, so the main shaft gears run along here, and then the lower pinion shaft gears run along there, but the gear set is mainly behind this plug, basically about to the split in the case for the center differential. So there's only like what, 4 horizontal ribs, and they're pretty tiny. 2 verticals. Look at this guy, there's the same 4, but they're way taller and way thicker. Now we'll have to see if we can spot any differences when we open this one up, but I don't think I'm going to open this one. I'm probably going to sell this off as a core. So we're just going to have to see what we can see on this one, on the inside of here. Basically there's a lot more meat. I wouldn't be too surprised if it's also thicker inside on the casing, but I don't think I want to open this one up, so we won't get to measure that, unfortunately. So from everything I can see on the external, this 6-speed transmission is way stronger. Now internally, from what I've researched and what I've been told, they redesigned the reverse gear, made it narrower, and they made all the first through fourth gears wider, and then they added the 6th gear in the center diff housing. So the gear set in this should be very similar to the gear set that you would buy from an aftermarket supplier, like what you would buy for this. The original 5-speed is a traditional rod shifted transmission, so that would bolt up and work fine with the factory Volkswagen rod shifter. The shift mechanism on this 6-speed, most likely due to the 6th gear that they shoved into here, they probably had to save space. This is a cable shifted transmission. So that's going to take a little more work to adapt. I don't think it'll be the end of the world. Ideally, I would probably just try to find the mid 2010s car transmission shifter assembly and just borrow that. But we'll see. I may end up making my own. So we'll just see how it goes. Best I can tell, this would be your forward and back motion on the shifter, so this should probably be selecting either 3rd or 4th, going back and forth here. And best I can tell, this would be your side-to-side motion in the on the shifter. So pretty sure I can verify that here and show you. Let's see if we can get this GoPro to stand. We'll point it down. All right. So if I go, right, so pretty sure this is the neutral point, which would be the 3/4 shift. So that's like you're not touching the left right at all. If I go all the way to the extreme here and I try to shift, I don't have a gear to shift into. But if I go the other way, there's a gear. I'm almost certain this is reverse. Right? That would be at the extreme edge of the shifter range. So then if I keep trying to click up while I slowly bring this back towards center, I will eventually find a gear to click into. Yep. There it is. Right? So I can go either way. Now if I let go, it still has a good amount of travel back to that, which should be a 3/4 shift. So this guy right in that range, that's probably the 5/6 shift, or it could be, I guess, the 1/2. I don't have the, I need to go find what the actual pattern is, right? And then if we go all the way to this extreme, this should be either the 1/2 or the 5/6. So all in all, this isn't too hard to work with, a little cable shift. If you were gonna do, say, a mid-engine, it would be way easier to work with a cable shift than to try and do a rod shift with the rod at the end of the vehicle, right? So we're just gonna have to see how it goes when we start taking this thing apart. So we are gonna have to do some cutting and some welding to the center differential housing of this 6-speed transmission. If you stick with the 5-speed, you can buy a aftermarket plate from SubaruGears that bolts to the split case of the 5-speed. And so that would be just a simple unbolt from here, take the shift mechanisms and whatnot in and out, bolt the plate on, good to go. Now for the 6-speed, we're gonna have to make some cuts along this center diff, and we're gonna have to weld in a plug where the splined shaft is. It'll make sense once we pull it all apart. I may throw in a couple still images here so we can take a look at that. It'll make a lot more sense. So all in all, it's going to be a difficult, long project. It's going to be a huge challenge. It's going to be fun. I am waiting on the internals for that transmission. I believe they're coming from Australia, so those will be coming hopefully by the end of the month. In the meantime, I'm probably going to try and source a engine stand for this guy, and we're probably going to start wiring up the Megasquirt ECU. So yeah, the nice thing about buying the JDM engine is they just undo the ECU connectors, and so we're just gonna have to trace out what each wire does. Intercept, injectors, or ignition and injectors. That's gonna be easy enough to get at and to splice into it. Probably gonna, well, we'll see when we get there, but we're probably gonna have to make a new set of intakes for this guy. This is a plastic intake. I mean, it works, but I don't know. We might go and do ITBs like on the little Volkswagen. So these two, these were from a Honda CBR 600RR, a street bike. And the cool thing about street bike carbs, they're an inline 4, but they make them in 2 halves for some reason. You literally just unbolt them, and you can make what looks like, you know, dual carbs. So I bought those used for like 40 bucks. So you can get really nice ITBs for really cheap. So we might do something like this, like that for this guy. I don't know if I'll be able to find throttle bodies that have throttle valves, and you know, everything's sized right for this. We'll just have to see when we start pulling this apart, see what the port size is, and go from there. And then yeah, so if I was gonna do that, I would probably do, I mean, we'll just see what we would get with throttle bodies, but we might just do you know, inline 4 version of those throttle bodies with a 1, 2, 3. If we can cut the one off without destroying the integrity, maybe we just go that route. If we have to leave it there because you know, no way to secure the shaft or something like that, then it wouldn't hurt anything to have a spare, you know, throttle body just hanging out with no manifold under it, nothing flowing through it. You know, wouldn't really do anything. So we'll get there when we get there. Yeah, all in all, got a lot of work to do, and just waiting for parts right now. We'll probably start the Megasquirt project soon for this guy. Still on the list to buy is a clutch and flywheel for this guy. I have to do a whole lot of research on what a good clutch and flywheel would be for this application. For, you know, so that's an 1,800-pound car right now, and it's gonna be, this engine's gonna be in 2-wheel drive configuration on some fairly small tires. So there's gonna be way less traction than a all-wheel drive Subaru car. So I'm gonna have to do some research on what I want. Obviously I need something that can hold the torque, but my goal is to not have wheel hop when under acceleration, under heavy acceleration. So the clutch is going to play into that. The compound on the tires is going to play into that. The weight, and you know, and the traction conditions of the pavement under you, all of that plays into it. So and the clutch material and type can affect that as well. So I'm going to do some research, going to talk to some some of the shops and stuff, and see what's a good idea to do. So that's it for today, and that's it for my introduction to the Volkswagen project. We'll see you later.